Hi, I'm Carl, and in this video we're going to have a look at questions 28 to 30 of section 3 of the pink booklet. This is a question about positron emission tomography, and we're told that there are these things called positrons, which are essentially positively charged electrons, and they're produced whenever you bombard oxygen with protons. So we've got this radioactive substance called fluorine-18, and you produce that by bombarding oxygen with protons. So because it's radioactive, it emits these positrons. And question 28 asks which one of the following nuclear equations represents the emission of positrons from fluorine-18. So I think it's easiest just to go through them ourselves. So we're dealing with fluorine-18, which is going to have this symbol at the start, and at the end we're going to produce one positron, and we're given the equation of it here. And if we're producing an oxygen species afterwards, we just need to balance it and see what happens here. So if we're losing one on the bottom here, one of these bottom numbers, one of these atomic numbers here at the bottom, we're going to end up with an 8, because we need to remember that it has to be balanced on both sides, and that gives us an 18 at the top. Now the question doesn't say that oxygen is a species that's produced, but if you were to reverse this, then you'd end up with this radioactive fluorine. So what they do is they get oxygen, they add a proton, and then you get this radioactive fluorine. And so if it decays, it's going to go back in oxygen species at the end. And that's why the answer for this one is going to be A. So now we've got a calculation to do. So question 29 introduces this new unit called the gray, or GY. So let's have a look at how they define it. They say 1 gray is equal to 1 joule per kilogram. And we'll come back to that towards the end of the equation. And we're told that the average energy from a single annihilation is approximately 10 to the minus 13 joules. And we're told this happens 10 to the 9 times per second. And the person is in the PET scanner for 20 minutes. Then we're asked to work out how many grays is someone exposed to over the course of this 20-minute period. So if we've got 10 to the minus 13 joules per annihilation, and that's happening 10 to the 9 times per second, that gives us the amount of energy that someone's exposed to per second. And that's going to be 10 to the minus 4 joules per second. So let's work out what it would be in 20 minutes. So 60 times 10 to the minus 4 joules per minute, or 20 times 60 times 10 to the minus 4 joules per 20 minutes. So you can multiply that out if you wanted to, but the person in the scanner is 60 kilograms. So if we're looking at the unit of gray here, it's going to be joules per kilogram. So if it's 20 times 60 times 10 to the minus 4 over 60, then you can just cancel these out like that. And so the answer is going to be 20 times 10 to the minus 4 gray. And it's given in a decimal here, so it's 0.020 GY. And that is going to correspond to answer D. And then finally, for question 30, it says which one of the following nuclear equations represents the production of radioactive fluorine in a cyclotron. So this is sort of what we were talking about earlier. A proton is being collided with an oxygen species, and that's going to produce radioactive fluorine. So something that is radioactive has the incorrect number of neutrons. And so knowing that, you could probably assume straight away that the answer is going to be D. But if we were to draw out the equation ourselves, we know oxygen looks like this, and we know a neutron is really just, a proton is just a hydrogen atom. We're going to produce this radioactive fluorine, which we know has this figure And so the bottom numbers are going to be balanced, but the top numbers aren't until we add in our neutron at the end. So this is the only equation that really balances properly. And so you could probably work out the answer that way. But if you just remember that radioactivity is a property that comes from a particular atom having the incorrect number of neutrons, then that could point you in this direction too. So that was questions 28 to 30. I hope that helped.